And now to the official material. It's time to get into some code. And we're going to talk about Ruby in a pretty quick overview. Of course, as you already know, the best way to learn any kind of a language is to write some programs in it. So I'm not going to start with this is a for loop and this is a string. You guys already know that stuff. So this is an intro to Ruby kind of at a high level for people who have taken Java. And in the specific case of UC Berkeley, many of you have also taken 61A, Structure and Interpretation of Computer Programs. You're going to see some of those ideas come back. And those of you who are joining us out in the wider world, don't worry if you haven't been familiar with those ideas, because they're cool and we're going to get to them. Good stuff. So let's start with just a laundry list here. What is Ruby? It's an interpreted language, so you don't compile it and run it. It's object-oriented, and as we'll see, it takes object orientation to a whole new level beyond what many of you probably are accustomed to, because everything in the language, even like an integer, is a real object. And the only way anything gets done in this language is you call methods on objects. It seems a little bit weird, but once you get used to it, it's a very powerful simplifying principle. It is dynamically typed. What does that mean? It means that there are types in the language, but variables don't have types. Objects have types, but the same variable can spend part of its life being an int, part of its life being something totally different. It is a dynamic language. And hopefully in the rest of the next couple of segments here, we're going to see some specific examples of what that means. Now, what it means on paper is that there's all kinds of things you can do at runtime after the program has already begun. You can add or modify new code. You can change the definition of existing methods after the code has begun. You can ask objects questions about themselves, and you can create new objects based on those properties. But the only reason this matters is to the extent that it makes programming easier to do and makes your code easier to maintain. So whenever I try to show examples of these things, the examples are going to be focused on how does this feature help you write better code? How does it make your code more readable? How does it make your code sort of, how does it make you feel like you've done a better job, like you've walked away and polished a sculpture of elegance? That's really what it's about. I'm into code beauty. All right, so some very basic conventions to get us started here. Names of classes. Yes, Ruby has classes. You're going to find out that they don't actually count for as much as you might think in other languages. In some elitist languages like Java, what class you are is all about what you can do. What you can do is determined about what class you are. Ruby is different. It's very meritocratic. What you can do is really just based on your abilities. Your class doesn't really matter all that much. This is actually true. So class names use upper camel case. If you've never seen the word before, you can figure out where camel case comes from as a term. Methods and variables usually use snake underscore case. So names of methods, you might find that method names can sometimes end with a question mark. It's idiomatic for a method that is supposed to return true or false, methods that you can use to ask questions about objects. You'll sometimes find that there are method names that end with a bang, not literally with a boom, but with an exclamation mark, the ASCII bang character, and that usually means it's a dangerous method. Calling this method could cause unintended side effects if you're not careful. So you'll get used to seeing that. There are constants. Usually constants are in all uppercase, all upper camel case. There are globals, but we know globals are terrible, so we're not going to use them. And there are symbols. This is probably one of the first hang-ups people get if they've not come from a language that has the concept of a symbol. So what's a symbol? The syntax for a symbol is just a colon followed by a string of letters and underscores and digits. But a symbol really is kind of like an immutable string whose value is itself. And the reason that in many cases you're going to find that there are methods in Ruby and in Rails where it looks like you could actually pass either a symbol or a string. Now, symbols aren't the same as strings. It's very easy to convert between them. There's methods toS and toSym. So when would we want to use a symbol instead of a string? Why do they exist? What we'll usually find is that when a symbol is involved, it connotes specialness. So if I see a function that's being called with the symbol :Rails, what I should interpret that to mean is Rails is one of a small number of special values that this function might understand. It's not a function that is prepared to deal, let's say, with an arbitrary string. So that's not always going to be the case, but very generally that's the case. And we'll see a number of examples of this. Variables, arrays, and hashes. You're all Java programmers, so this should be quick. There are no declarations. You are free from declarations for the rest of the semester. You can have local variables. You have to assign them before you use them. And as we'll see, when we're defining classes and objects, the instance and class variables spring into existence with the nil value, which is also a value that means false in Ruby until the first time they're assigned. So remember I said that variables don't have types, but objects do have types. Here's a variable x that I'm assigning to an int, and then I'm assigning it to a string, and that is totally cool. The int and the string are different types, different classes, but the variable to which, the variable that refers to them doesn't have to have a type. This we can't do because there's no declarations, right? There is a class integer, but we can't put the classes in front of variables. Variables don't have classes. So some of this is just going to be breaking out of habits that maybe you've gotten into if you're coming from the Java world. We have arrays, plain old linear arrays, and as you can see from this simple example, arrays don't have to have all the same kind of object in them. So in Java, you talk about an array of ints or an array of foo bars. In Ruby, it's just an array. It can have whatever it wants, and the elements can all be different, as a matter of fact. We can assign the elements using a subscript. Subscripts are zero-based. We can also ask an array how long it is, and we'll talk about many more interesting methods that arrays come with, but they behave the way you'd expect. We also have hashes. Some languages call these associative arrays. If you've programmed in a language like Perl, you're probably pretty used to these. Python has them. They call them dicts or dictionaries in Python. So here's an example of a hash literal. You put it in braces. And again, hashes are what? They're a mapping of keys to values. But because variables don't have to have types, the keys can be any type, and the values of those keys can be any type. And they don't all even have to be the same. So here's a hash that has two keys. One key is the single character string A. Another key is the symbol B. Remember, that's different from the string. And in fact, what is the value of the symbol B key is an array. So again, just like with arrays, we can mix up the types of the keys and values. We can dereference that array and set its 0th element to something. And we can ask the hash what its keys are. Then we get back a plain old array, which is just a list in some arbitrary non-guaranteed order of what the hash's keys are. And there's ways to go through them as well. Methods. Everything is passed by reference. Everything except integers. We'll come to that in a minute. So I can define a single, here's a function foo that takes 2 arguments, and it actually returns an array or a list of 2 things. I can define functions that have arguments with optional values. So this says, when I call the foo function, the second argument is optional, and if I don't have a value supplied for the second argument, it gets 0 by default. And when I call a function like the one I've defined here that actually returns a list of things, I can assign the result either to an array, and then I can dereference it, or I can just assign the result to individual variables. So again, a lot of this stuff, it's in the reference manuals and so on. I'm just trying to give you kind of a very high-level whirlwind tour of the language so that you get used to reading code in a language that you maybe haven't seen before. OK, control flow and statements, moving right along here. Statements end with a semicolon or a new line, but a new line is way more common. In fact, getting back to the code beauty thing, a really nice thing about, one of the other things I do besides writing Ruby code and teaching great students at UC Berkeley is I'm a musician. I do musical theater work. I do a lot of orchestration. And if anybody play jazz, one of the great things about putting together a chart of jazz music for a jazz musician is you want to minimize the number of marks on the page while still communicating everything that the musician has to do. I tend to think of programming the same way. In fact, I've gotten to the point where I like using single quotes around strings instead of double quotes, because it's like less pixels on the screen. I'm serious. It's a compulsion. But where I'm going with this is that in Ruby, even though semicolons can be used to end statements, you never see them. You put each statement on its own line because that's easier to read. It's less stuff per line. Now, does that mean that you can't break a statement across lines? Well, it means you have to be careful with the parser. Here's 2 examples of a statement, one of which will parse correctly, where the line break is after the word unless. I'm going to raise a boom exception unless the ship is stable. It would be incorrect to put the line break after raise boom because this statement by itself, raise boom, is actually a legal Ruby statement all on its own. So in this case, the interpreter would be confused because it stops parsing the statement here, and then I have this unless, and where am I? We have all the same basic comparison operators you've already seen. As we'll see in a moment, the equal twiddle and bang twiddle are used for regular expressions, among other things. There's Boolean true and false. There's Boolean nil, which evaluates as a false value but isn't the same as false. Don't panic. And then we have the usual control flow constructs. So we have if then else, along with else ifs. We have while or until. And what are these weird things down here? 1 up to 10 or 10 times. You can try to think of these as loops, but I'd really rather you didn't. In a couple of more sections, we're going to talk about blocks and iterators. And what these really are is a completely different way of thinking about iteration. Instead of thinking about loops, we're going to think about objects that manage their own traversal. Let me say that one more time. Objects get to manage their own traversal. If I am a binary tree, I get to manage how my elements are traversed. If I am an array, I get to manage how my elements are traversed, and usually that would be in straight line order. In fact, I can define an arbitrary kind of object or data structure that if it has more than one element, it gets to decide how those elements are traversed. And as we'll see, these examples containing up to and times are really just a way of saying, I'm going to in place define a sequence of numbers, and it's going to manage how it's traversed. But we'll come back to that later. Strings and regular expressions. Regular expressions are so your friend. This would be a great time to start reviewing regular expressions. We'll do a very quick review here. And there's a great site called Rubular, seriously, rubular.com, where you can test out regular expressions against strings and make sure that they do what you want. So how do you express strings? We've got double quotes. We've got single quotes. We've got %Q, which means treat this string the same as if it had been in double quotes. So why would you use that? Well, for one thing, you could put double quotes into the string, right? Similarly, %q, treat this string as if it had single quotes around it. And what's the difference between those? Well, one example is in a double quoted string, you can interpolate an expression, right? And notice that I say an expression. When you have a pound braces construct inside a double quoted string, you could put any Ruby expression there of arbitrary complexity. Now, it's bad form to put something in there that's super complex. Just because you can do something doesn't mean you should do something. But in a single quoted string, that doesn't work. Single quoted strings are like verbatim. What about regular expressions? For reasons that you'll understand better after you've done some Ruby programming, you can actually put the string and the regex on either side of the equal twiddle operator, which is the matching operator. So here, I'm going to take the string, fox@berkeley.edu, and I'm going to match it against this regular expression. Now, as you all know, because you all know regular expressions, and I'm just going to review it, but as you all know, this regular expression says match 0 or more of any type of character, followed by an @ sign, followed by 0 or more of any type of character, followed by a dot. The backslash means this dot is not a wildcard, it's actually just a dot, followed by the letters edu, followed by the end of the string. So in this case, the regular expression match would succeed. Now, what about the fact that edu is in uppercase on the left side but lowercase on the right side? Well, that's okay because the trailing I on the regular expression says ignore case. And again, if you've programmed in other scripting languages like Perl or Python, some of this syntax is heavily overlaps with those languages. I could switch the order of these on either side of the equal twiddle. That works just as well. The return value of this expression is if there was any kind of a match, I get a true value. If there was no match, I get a false value. And if the expression contained parenthesized groups, in the event of a match, the variables $1 through however many groups there were capture the partial matches. So in this simple example that I used, $1 would evaluate to Fox because this first group of any characters before the @ sign matches the first group of characters in my name. And $2 would match Berkeley because the second group of parens matches this group of characters that's before the .edu. Learn them, know them, love them. And lastly, other ways that we can write regular expressions, the slashes are sort of the most common idiom. Many languages, including Perl and Python, also use them. But you can also construct them the long way by saying construct a new regexp. There's also this %r brace notation, which you don't see very often, but just in the interest of exposing you to all of these things. Okay, we're going to do a pure learning question here. Okay, ready to test your regular expression chops? Here we go. This is actually a bunch of things at once because you need to think about arrays, you need to think about hashes, and you need to think about regular expressions. So, which of these 4 expressions will evaluate to not nil? Which one will, in other words, which one will result in a successful regex match of some kind? I'll let you parse it for a bit. Okay, I think now we should take a vote. Your brains are going to get used to this, don't worry. Okay, ready, everybody? And let's vote. Vote, 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 vote.